So there was a question on the wiki which basically asks, when does a struct become a class? Which means if I start with something which is just basically, in the Java terminology, has just fields, right? And maybe setters and getters. When we start adding functionality, one is across the line from being conceptually just a structure and conceptually being a class, right? Any comments on that?
Right. John heard about a dozen times, but it has to have operations that correlate to the data. Whatever your fields are, you want to have operations that deal with those fields. Right?
Yeah, and that boils down to then what's the abstraction that thing represents, right? Which then tells you what sort of operations you need.
Yeah, in Java, it's been tempting to use structs because you can only return one value. So a lot of times I just want to get 2 values out, but then I don't want to lose the letter grade on using the struct. But I've always been able to find a different way to do it.
Well, but for me, whether you say struct, name, curly bracket, or class, name, curly bracket is irrelevant, right? It's conceptually, what is the thing doing?
Oh, yeah.
Yeah.
I want to get struct -5 again.
Yeah, I assume that's the motivating factor behind the question on the wiki too, is that? So the other question becomes, what is the abstraction that thing represents? And what operations do you do on that abstraction?
And then the other side of it is have methods and data.
Right.
Then you also, in terms of operations.
Right. Yeah. Any other questions? No, yours. Everyone was engaged and talking and walk in, and now they're dead silence. So last time we talked about the factory method, right? The template method. Once you talk about the factory method, then it's reasonable to talk about the abstract factory. And the motivating example here is when you want to build a cross-platform toolkit, right? And so you want to do the menu, Mac OS, Windows, maybe some sort of Linux system. But then all the systems, the calls you make are completely different, right? I mean, the calls you make to create a menu in Windows is completely different than what you do in the Mac, which is completely different than what you do, right? And so then we can, sort of make some of the menu class that abstracts all the differences away, and then you call a method that, here's the 3 items on the menu, but then you implement 3 different ways for different platforms, right? And then there's windows, there's menus, there's buttons, all the widgets, right? So for each widget, you're going to have if you've got 3 platforms, 3 different subclasses for that widget. But then the problem is, as soon as you start hard coding someplace, which menu or which widget you're going to create from which platform, now we're dead, because now when I want to change my program to that platform, I have to go find all those spots where I said Mac, change it to Windows, or change it to Linux. We don't want to do that. We want to be able to basically say new menu, right? And then get the right one for the platform. And so when I move the program from one platform to the other, it does the right thing. And so then what the Abstract Factory does is we create a class, that will create all the components we need. Right? So a window, a menu, a button, right? And then we subclass this factory for the Mac platform, the Windows platform, right? The Linux platform, right? And then, of course, you do whatever you have to do to create those objects. And now we have we can pass this factory around, right? And then when you want a menu, you ask the factory to create the menu, right? And so if you're on the Mac platform, you instantiate the Mac factory, and then you get, when you say give me a menu, you get a Mac menu, and then you can, so there's only one spot you have to worry about which platform you're on, right? When you create that factory, you say, okay, now I'm going to create the factory for Windows or Linux or for Mac.
What if we use a instead of abstract? The problem is we are saying new class name. Instead of using abstract factory, we inject the.
Well, so you have to inject it somehow, right? And so you're going to inject all of them? And where are you going to inject them?
But now the injection clients not.
Different places. So why not inject just the factory and do it once, right? So then when you run it on Windows, you inject the Windows factory, as opposed to having to inject a menu and a button and a slider and, right? So that's that factory, right? You just want to, right? Get things that go together. We create a factory to create them, right? So we can vary based on the factory, rather than have to worry about it in different spots. Right? So create the factory. Now we get all these things that are supposed to go together. Right? So again, it's not a complicated idea, right? It's just like, okay, in this case, we want all the Mac widgets. We need to create them, so let's create a factory to create, list each one we need to create, and now we can create it. And the text talks about, how you create things. So there's different ways. One is, your factory just consists of a bunch of factory methods, right? You say create window, and so you return a new window. So your abstract factory it's just a bunch of factory methods that go together. Yeah. And so here, so this is basically a factory method, right?
Yeah.
And then, so my abstract factory is just a collection of factory methods logically grouped, right? Then we can start doing things like, well, we'll create, subclasses. We'll just instantiate each one, and then somehow when we want to create it, we clone it or make a copy and return that, right? It's still a basic idea. And instead of saying new each time, we'll do it once in my constructor, and then I can clone it or copy it or. So different ways of creating my factory method that. And the claim is that this way we can have multiple ways of creating the same thing, but I don't necessarily the difference in the sense of I could create a bunch of factory methods of the same thing, right? Another one, use a prototype pattern, which we haven't talked about yet, but we can create prototypes, and we'll talk about that later. But again, it's the same sort of thing. We're going to create a bunch of objects and use those as the prototypes for the things we want. But even if we're using the abstract factory, and if I create a menu, I can still in Java, I can still downcast it, right? And so what can we do to make sure that doesn't happen? And we'll talk about a different pattern we can use to solve that problem. Let's see, before we go on to Singleton,
You have all the base class, type class,
I can still typecast it, right?
Yeah, we can, but we avoid it and having all the methods and polyform methods we're going to use. I think in Java, you put in some package and then access.
Yeah. So if I hide the class name, I can do that, right? But we'll see another pattern which will help. Yeah. Now in Java, right? Java is cross-platform, so I can write an application, right? And I can run it on Windows. I can run the same application on the Mac and the same application on Linux, right? So how do they solve this problem? Right, and some of you are doing this now, right? You're writing an application for the assignment 2, and you're using JTable or Swing, right? And you can take the same binaries, right? You can compile it, create the program, and then run on different platforms. It still works. right?
Yeah, but that's redrawing. That's the whole thing with AWT, right? They try to do this, and then that's when they come up with the saying, "Right ones debug." So they redid it a swing so that they can have consistent behavior on every OS. It's not really, it's minimally using the native, whatever.
Yeah, but how do we get the native components? At some point, they do go down and use the primitives for the native widgets, right?
I think they just use plain. I mean, only the things that are in AWT. I think almost every control is custom in a bare window. Well, I mean, that's just been from what I've been reading about.
So you go back to AWT. How do you do it in AWT? Yeah. But now, how do you make sure that the application only has one instance of the factory, Abstract factory? Yeah. Singleton, right? This is the simplest pattern. In Java, you can learn like 3 or 4 lines. It's also most controversial. And so the goal is to provide one point of access for a single instance of the class, right? That's it. The name says it all, right? There's only one of them. So there we go. Here's an example. So I have a counter class, and so just some create example. And so it has a private field, and then I have a private static field that contains the single instance, which in the pattern they say instance. And then I make the constructor private, which means the only code that can instantiate it is code in that class, right? And then I create a static method called instance, which checks to see whether that field is null or not. If it's null, it then creates an instance, and if it's not null, and then it returns it, right? And so there's a global point of access because you've got a public method in the class that returns the same thing over and over again. And there's only one instance because we've hidden the constructor so no one else can call it. And the only way to get an instance is to call instance method, and that checks, makes sure it's right. So we're done. Yeah, so that one of the problems with the singleton pattern in Java, there are a number of different ways in which it fails. Talk about that in a minute. Yeah. So there are a number of examples. One is in AWT, if you want an abstract factory for the right platform, right, for the widgets, you only want one. You only want one factory, and you want to make sure there's only one because you don't want somehow to create a second one of a different type. Perhaps a even more important example is the Java Security Manager, right? When you run any Java program, there is a security manager which checks to make sure whenever you do something, whenever you access a file, use any system resource, right? We need to check to make sure that that program has the authority to access that resource, right? Now, as people know about it when you run applets, because you want to make sure that you don't do certain things because you're downloading code from the internet, right, and running it on in your browser. But even when you run a standalone application on a machine, right, in Java, there is a security manager checking every time you use any system resource. Do you have, can you open a file? Can you write the file? Can you write to that file? Can you have access to the microphone, access to the camera, all those things? It checks. And the problem is now you don't want the other program the ability to create a second security manager, right, to override the first one. And it has to be everywhere, right? Any place in the Java library where you actually access a system resource, you have to check that security manager, right? So it has to be everywhere, and there's no way to pass it along, right? But it has to be over here, it has to be over here, and these two are unrelated. And so we need a point of global access, right? And so Singleton. Another example is when you're logging. You basically want different parts of your code to log different things, but you want all those things to go to the same log, right? And again, those pieces are unrelated. It's not like you can pass this logging manager around. If you did, it'd be like really complicated because you have to pass it everywhere because you don't know where you're going to need it. And so you want, instantiate one logger, and you need access basically at any point. Null object we'll talk about later, right? So there are valid uses that where we need. Make sure there's only one of them, and we need global access, right? So we've all been told that globals are evil, right? I mean, at some point early on, when you in undergraduate curriculum in computer science, they say globals are evil, avoid them. And the problem with saying things like that is then people believe it. And the problem is, if globals are evil, why do programming languages give us the capability of creating globals, right? It's not like we discovered this 2 years ago. I mean, we've been saying this for decades, right? And so why do languages allow this? Well, the answer is, look, we need it, right? The Java Security Manager, we need a global access to a security manager. End of story, right? We need system.out is global, right? If you're going to print the standard out, we need a global access to that because, again, we can't pass that around because different parts of your program, unrelated, may want to print out standard out, right? So there are times when we actually need access to a global variable, a global thing, right? But most of your data in your program does not have to be global, right? And so, so the first reason is controversial is, well, okay, the singletons give you a global point of access, right? Do you really need that or not? Java Security Manager, absolutely, we need it, right?
One of the things that was design something as a single, and then later decide, wait, actually, I need two different log files.
Right.
And then you might end up changing all that code. I mean, at least there's an access point, and you can maybe come up with some way where your access point can be different objects.
Yeah, and the pattern talks about that. It says, you can return multiple copies, right?
Or different objects.
Different objects, yeah. And so for loggers, when you call for your loggers, in Java, you do it by class, right? So different classes can have different settings for for the logger. But yeah, so the real question here is, you don't want to abuse a singleton to use a singleton where you don't need it, right? You really don't need access globally. Another complaint is that whose responsibility is it to limit the number of objects created from a class? Should a class deal with it, or should some other entity be involved? Yeah, it's hard to deal with polymorphism. Yeah, here you have to be careful because, that if your singleton has state, the state doesn't go away until you restart the program, and that can cause problems. Right? Okay, implementations, right? Why not do this, right? This also gives you global access, right? And one of them. You can create lots of objects, but there's only one count, right? And one increase. And they all have the same value.
Yeah, I mean, you can get a similar effect, but this is effectively a global function, global method,
right?
Versus a global object. So
right.
One is more, I guess, oriented.
Yeah, and so if you ever decide you need more than one copy, you're dead here, right? Also, how do you access the increase method? Well, it's counter dot increase, right? So if you want to change to an object more than one, you have to, all your syntax have to change too, right? Because if you want more than one object, it's going to be object dot increase as opposed to
with Singleton, you're just using it to create the object.
Right.
Then you don't have to use it every single time.
Right. Plus, the other one is occasionally run into people who like to make everything static and they don't realize what they're doing. And so, I ran into like one or two students that did it in the first assignment. Things were static. It's like, no, don't make that static. So you really want to save static for those rare times when you actually need it. And what about this one? What?
That makes sense.
Um,
Oh, wait, no, never mind.
yes, I should really, right. So this increase should actually return instance.count++, right? So one problem is what if I assign instance to null? If I change this increase to return instance dot count plus plus. What happens now if I change this value to null? Right. So people talk about two useful properties of a singleton. One is being lazy, particularly if the object is big, then don't create it until you actually need it. And the other one is making it thread safe, as you pointed out, right? So here is sort of the recommended implementation in Java. Is this one lazy? It is lazy.
When you think it's static class.
Well, so there's two issues we're talking about. Is it being lazy and making sure it's thread safe, right? Lazy. So now we have to ask the question, when is a class loaded in Java? Right? And a class in Java is loaded into the VM when you run across the first usage of that class. Right? And the first use of this class is right here. Singleton holder, that's when this is going to be loaded. Right? So when the first time you call instance on the counter class, that's when your Singleton holder will be loaded. And now it's thread safe because loading classes is done in a thread safe way. So it's a pretty subtle thing, related to the fact of how classes are loaded and when they're loaded. No, but I mean, we can. That's easy to fix. Yeah. We can make it synchronized, but well, no. Well, the question is that operation atomic?
Because I know there's an atomic version.
Good.
You gotta get it. I got to.
Right. Yeah. And so this works too, right? When you have this final static field, which you assign a counter to, but that will be called as soon as this class is loaded.
What you had before was just image construction.
No, it's actually in a inner class. And the difference here is, as soon as this class is loaded, then all those fields are going to be all the stacks are going to be initialized. And if the class is loaded, when you first come across a use of that class.
The outer class.
Right. Until you come across reference to it. Yeah. Like I said, so it's a very subtle implementation based upon when classes are actually loaded and how they're loaded. Yes, right. Yeah. So that's not lazy. And the more common one you see is you make instance synchronized. Once it's synchronized, then right, you only get called only one thread is allowed in there at a time, and therefore it's thread safe, and it's also lazy because you don't only instantiate the first thing we call instance, but you incur the overhead of synchronization every time you call it instance. But it's also far more understandable, right? Everyone's going to understand this one. If you're a Java programmer, you know synchronized, and you're not dependent upon knowledge of when classes are loaded and how they're loaded. And
all of the application subject, and every time it's sync, every time lost.
yeah, but then the question becomes, how often is that method called? Right.
But we say, I mean, if it's a global object, security, logging, it's going to be reused. It would be, I mean, less frequent. It would be very frequent. I think.
It depends on what your program's doing, right? If your program's doing lots of computation and only at the very end writes to a file, then there may be only one spot in your entire program that needs a security manager, right? So it depends upon what's going on, yeah. And yeah, the templates, you can't use templates with the Singleton. Yeah. Because to do this, you need to know what the type is. Yeah, it won't compile, yeah. Unless I modify the compiler to fix it, but and now we get to the point where in Java the Singleton doesn't work. So Java is garbage collection, right? So objects get garbage collected and then memory is reclaimed. Classes can also be garbage collected. So if you've got a long running program, I mean, that's common these days, right? Programs that run for months, on the server, right? They just run forever. And if a class is loaded and is not used for a long time, and then you need to reclaim memory, then okay, there's no instance of that class around, and so we can reclaim the class. We can garbage collect the class. If you garbage collect a class, then the singleton goes away. Which means if it contains states, then when you call for it again, you get a new copy. And of course, the problem is, if you're building a library function that people can use, right, then how do you make sure that when they use your class, right, your singleton class embedded in your library, that they don't have garbage collection for classes? I mean, you can turn it off, right? But that's a compiler flag.
Can you give it a reference? Because I had a problem with IIS, kind of similar to this, where I was running database stuff in the background, and IIS would be like, no users, go to sleep.
Right.
So I have to have my background process ping the website. But I was thinking if the Singleton somehow had a logic itself.
Now I think the newest they see the cyclic one. If it's
Right.
cyclic one, they cannot spell it out.
Yeah, so what you need to do is you need to find a place that you can put a reference to your singleton that won't go away.
Yeah, that's it.
No, you take your singleton and assign, put it in a system
Yeah,
property.
but I mean, like, the compiler would be too smart because he's saying, like, if you made an inner class inside your singleton that have a reference to everything.
No, so for example, in Java, you have system properties, right? And then you can add system properties as a dictionary, and it doesn't go away. So if you then add your singleton to the system property, right, now you have a reference that won't go away. But it's still like awkward, right? And now the problem is, in theory, this happens, but there's no way to make it happen.
So that's all we have.
Yeah, it's going to be a very rare bug, and so another case is, okay, when you've got servlets, right? So when you have two different clients that want to instantiate the same servlet, right? You want those to be completely separate. So what happens if in your servlet, you write an application that uses a servlet, for web pages, and inside that servlet, you want a singleton? Well, servlets are designed so that they're completely independent. I mean, when we say it's a servlet, the same servlet but different users, they're completely independent. Which means the way they do that is they use different class loaders to load each one, right? And so even though it's a singleton, each servlet partition will have a different copy of the singleton, even though you do the so it may be what you want, but it's not going to behave the way you'd think, because you go to your class and it says, private constructor, do everything right, and now you've got multiple copies of it floating around. And also in the same context, it's possible to force a class to reload it. And if you reload a class, that means it's going to reinitialize your singleton. Again, it's going to be very rare. It's going to happen very rarely, but when it does, it's going to cause you lots of pain.
When you load the class, second option, then now they have to
Well, if you reload the class, right, if a class has a static field, there's only one static field, right? So it should overwrite the old one.
there will be still one object, but you can
And so the value will change. And then, of course, you can serialize and deserialize it.
Because in Java, there's a finalize, right? Like, you actually get like a destructor when
Right.
you have garbage collects.
Right.
So you dump it.
Again, very rare cases, right? But so so there are cases in Java where singleton doesn't work, right?
So the security manager and trace logger and everything are likely stateless, so that if they go in,
The security manager is not stateless. Why? Because there's actually a global system file, and then you can have a local file per user, which changes the permissions. And so I don't know if I assume they don't read that file every time. I assume they read it once in startup. And if they read it once on startup, then there's state, right?
Well, I mean, if it goes away, though, it has to back up again, recover where it was.
Yeah, unless someone changed the file.
For the worst case, Singleton object needs to save its state like a database process always. How we are sure if the second, even if it's very rare, but if it comes, we always need to save the state in the database.
Well, first of all, these are pretty rare circumstances, right? If you're not doing a servlets, then all those issues go away. If you're not creating a custom class loader, that goes away. So then you only have to worry about classes being garbage collected. And like you said, in the security manager, if it's reading the file, then it's pretty much going to be reinitialized the same state. And you have to ask yourself how many times you write a Java program that runs for months and months, right? That uses a singleton that.
And these things that you're mentioning could happen with any static.
Yeah. Yeah, and Ruby. Well, it makes it so that you can't serialize it and deserialize it and have two copies. If you make it clonable, then you can clone it, right? Now you've got two, right?
Yeah, you put it as like that.
Yeah, I mean, if you want a singleton, you don't have an implemented clonable interface, but our third pattern for the day is the adapter, and the picture explains the adapter. And there are a number of people in the room that are familiar with this problem, right? You've got, in the physical world, you get a plug that wants a certain shape, and then you put the outlets are a different shape. And so what do? You build an adapter, right? And then one of the questions about adapters is how much adapting do you do? Well, it depends upon your device, right? In this case, sometimes there's a physical adapter like that works, but sometimes, no, it's not doing enough adapting because you have to worry about the voltage, right? And the frequency of the voltage, right? And then you need a bigger adapter because you need a transformer to step the voltage down or up and change the frequency. I mean, changing the frequency is harder because a single transformer won't do that, right? It just change the voltage. And we reason the adapter in software for the same reason, right? You've got some class that you want to use, and you want to use it in a context where the interface isn't right, right? And those of you using the JTable for assignment 2, right? You need an adapter, right? Why? Well, because the JTable, it defines an interface how to interact with a cell, right? But then how do you make your class work with that JTable? I mean, either your class has to implement that interface, which is like, why does my cell object have these weird method names that don't make any sense? Or you can have an adapter, which takes your method, right, that makes sense in your cell class, and then transform the right method into, and the JTable can deal with, right? Right. So that's.
So with the JTable, the table model.
Yeah, the table model. Yeah, right. I mean, and it defines how it interacts with it.
You have to define like how to get a value back.
Right. Yeah.
It's only
yeah, it's how to get the value out, right? And
or you've got your cell class and your JTable class and the adapter.
Right. Yeah. And so and it's because the model expects certain behavior, right? There's a certain interface that it works on, but that interface doesn't make sense for your class, right? And so you just put an adapter between the two and good to go, right? And there it is, right? The JTable example where you, requires a table model, right? And then you have an address book or a cell, whatever it is, and you make that, in this case, an address book. It's an abstraction that you implement that satisfies what an address book should do, but how do you display it in a JTable? Well, you create an adapter, right? And all it is doing is mapping where get that value at to the right call on, in this case, the address book. Right? So I talk about two different types. In the Java world, you use the object adapter, right? Some client expects some method, and you create an adapter, and that the method the client wants is then calls the right method on the actual object. That's what the JTable model does, right? In languages that have multiple inheritance, which is pretty much C++, you can do it with a class adapter, and that is, you've got basically two interfaces you want to merge together, and so you can subclass it, and then they implement both of the methods, and then you can map it. But it's only of interest to languages that have multiple inheritance, which is pretty much C++, right? I don't know of any other language that do multiple inheritance. So most people, there's only really the object adapter. Because the class adapter, your adapter subclasses both the new interface and the old interface, and then you can merge them together.
So you could do that in which target.
Yeah, but the interface, yeah. Right, and so, I mean, there's a simple example where you have a square peg and round peg, and now you, right, subclass them both, and now we can do the mapping there. Right, object adapter is where you got a field, which is, right, the old interface, and then the adapter has a new interface, and it then maps new interface to old interface methods. And so that's the question, right? And the answer depends upon the situation, right? If the country you came from, the country you're going to, have the same, close enough to 60 hertz, right? Then we're good. If it's not, then okay. Now that little adapter doesn't work. We need the bigger adapter, right? Where the voltage is too different. Okay, both are different. Then now we need. I don't know. Does anyone have any adapters that can change both the voltage and the frequency of the current? Anyone? What's the frequency of the current in India? Someone must know. I mean, come on. I mean,
Only voltage.
yeah, I mean, if the difference is between 50 and 60 cycles, you can usually get away with it, right? But if it's a larger difference, devices won't be happy, yeah. And so how much adapting you do depends upon the situation, right? It may be just be a simple one-to-one mapping, or it may be that when the old interface is different enough that you have to do a lot of work to map it to the right thing, right? If it's the same voltage and just different shape prongs, then that's easy, right? But if it's different voltage, then you need that transformer, right? So you have to do more work, right, to actually. And so yeah, we can make adapters that go both ways, that work with both the old interface and the new interface. That can be used in both places. So here's an example in Ruby where Flasher has an interface where you can toggle between whether it's flashing off or on, and there's also a pause and a resume, and we may want to then have the mouse trigger it, right? So mouse event will trigger it. So you may want to click to toggle the flashing off or on, and enter pauses it, and exit resumes, right? So you move the mouse over, it'll say stop flashing. And so now we're going to ask, how do we do that, right? Well, adapter, So in our flasher class, we can make it a listener. But now it's sort of weird because we've added the methods that don't make sense to the flasher. So using an adapter, right? How can we adapt it? And so the straightforward adapter is we create a separate class for our adapter, right? And we give it the methods of the new interface, and then we map them to methods of the old interface, right?
Is this why in Java when they implement a listener, they always call it an adapter? Is that related to it? Because you're adapting from their UI to your application?
They
Is there
call
a
it.
reason for that? Like if you for example, the default for Abstract, if you want to implement the listener, mouse listener, their class is called Abstract Mouse Adapter. It implements mouse listener. I was wondering why they don't call it Abstract Mouse Listener when it implements listener. It's like a term change.
Well, but when you subclass it, what are you doing? You're taking that mouse enter, right, and you're doing something else, like we're doing here, right?
Yeah, so that's where the adapter comes from.
Right. Yeah. Yeah.
You're adapting from their UI to your application.
Right. It's basically mouse entered. What do you want to do? Right. And that's what we're doing here is right. Mouse entered. Well, I'm going to call pause on my flasher. Right. Mouse exit, and I resume. And mouse clicked, I can call toggle.
But then in model view controller, the adapter is a controller.
Well, when we talk about the model view controller, we have to ask, what is the controller? Now, in the initial model view controller, the controller really just dealt with mouse events and keyboard events. And it then just routed those events to the right place. Do they go to the view or do they go to the model? And that was the goal, the functionality of the controller initially. Then when it got adapted to places like the web, what does the controller do, right? It took on more responsibility than the original model view controller. Oh, it does all kinds of things. It routes things, I get a message and then a request from a client. So where does it go? Does it go to that code, to this code? And then when you get things like in iOS development, they've got a controller class, and basically a lot of your logic ends up there because when there's an event that's triggered, you click on a button, the button then calls a method on the controller class, and then the controller does something, right?
But your controller to do something, the model view.
That's in theory, but in practice that becomes complicated, hard to do sometimes.
I tried the model view controller. Takes on.
Yeah, that's what initially did, and actually, the first implementation was in Smalltalk. Initially, it was very painful because you'd write your model and write your view and then write your controller. Like, okay, now I want my menu, right? I want this keystroke to call, and then I have a function over here, do this, and then controller would say, oh, it's control K. Okay, I can call that function, right? It's like
it doesn't split
Yeah, and then eventually they said, well, we can just hide that from you, and when you can basically say on your menu item, Control K calls that function in your model, and it's still there, but in the background. It's much easier or less painful.
I'm just wondering, my client class, and this is let's say my target class session. So this middle class is an adapter.
Mm-hmm.
This adapter is always mapping one-to-one, like
Right.
toggle to
Yes.
pause to pause. Let's say if I have a scenario where my one method, I'm calling my middle layer, which has calling two methods.
Mm-hmm.
So it's still gonna be called as an adapter
Yeah.
pattern or something else.
Right.
Because in web we say service layer, like
Right.
we call a service layer which has a many down layer calling. So in a way, both adapter and service layer seems to be a similar thing.
Well, that starts to get complicated, and if you start looking at the structure of these of this pattern, it also is the same structure you get in the state pattern, right? Or in the strategy pattern. Now, the structure here is, my adapter pattern. My adapter has a reference to an object, and I forward requests onto it, right? Does that mean any place where I'm forwarding requests is going to become an adapter? Not necessarily, right?
So does that mean adapter is really when you have two interfaces and you don't really have control of
Yeah.
to marry two things?
Right. Yeah. Yeah, if that's what we're doing, right? But if it's just routing, right? I've got a routing, and routing tables aren't adapters, right? It's like, so in the web world, right, that happens a lot. You get a request in, like, okay, where does it go? There's a routing table, right? It's, okay, this URL goes to that. You call this code, this one. You don't call that adapter. It's just routing, right? Which is different. It's solving a different problem.
Also an example of
No, because again, what we're doing in Memento is different, right? The goal is different. I want to save that state in case I need it later.
it is pretty much a replica of the originator, right? It
Right.
needs to have the same properties as so that I can route. I mean,
But with these patterns now, we're going to see a lot of them where basically there's an outer shell and an inner object, right? And the outer one will forward some or all or parts of the request to the inner one, right? And so then the difference becomes, what problem are we solving? The mental patterns, like I want to preserve that state in case I need it back later, right? Here it's just, well, I got a Flash interface and I got a mouse interface, and I need to map one to the other. Right, and now when we're doing simple adapting like this, we can parameterize it. And so in Ruby, they got this thing called a forwardable. And you basically create a table that says, oh, look, on mouse click, just call toggle. A mouse enter calls pause. Mouse exit call resume, right? Because all we had is a mapping, right? And mouse click calls this function. So if you got a simple mapping like this, it's basically a table lookup. What do we do, right? And this one we do that. And so in Ruby, we can create that table and simplify what's going on.
Dev delegator, is that part of the language?
Yeah, that's part of the language, yeah. So then, if simple adapters, we can also then pass in have parameters which are mappings, right? In Ruby, well, you basically passing in the name of the functions, and then we got ways of calling it. Now with lambdas, we do the same thing, right? If it's just you're dapping one method called another method, then we can just pass in a lambda which does that, right? But unfortunately, lots of times when you're doing the adapters, you have to do more work, and this won't work. You actually have to create a separate class, right? And there's, so we're passing in lambdas to make it easier. Now we just so it's 3 new patterns. What's that? Yeah, that's Ruby, yeah.
Each and every language for KPD. Is that Java is not supporting this one, or is just you just want to give a flavor of it?
Well, so what's going on here is different languages have different capabilities, right? But also, since I allow people to do different languages, it's sort of nice occasionally to show them their language, right? And you're a graduate student, so you should be exposed to different languages.
But sometimes get confused whether this is possible in Java. Like,
it's possible now with lambdas, yeah.
Not specifically this one, but generally.
Yeah. Okay, I will see everyone next week.